This is Algebra 2 with Trig, working on the 5A1 and 5A2 review. So in this first group, we are going to express as fractional exponents or rational exponents. Your radicand goes inside your parentheses. Your index is always your denominator, and your exponent is the numerator. Index is a 2, so you get 2 over 4, and that can actually be reduced. Oh, I wrote that backwards. Take that back. I did exactly what I said not to do. The index is your 2. Okay. You can call that 289 if you wish. Now this isn't in radical form, so we're going to write it in radical form. So the denominator, remember, is your index, and your 7 can be on the inside or it could be on the outside. Sometimes there's different advantages to where it goes for what you can do with it. But outside's fine. -6, cube root, numerator would be squared. So we could write this as 1 over the cube root of -6 with a positive square. All right? And you could even call the inside 36. Because you're squaring the 6. You're actually not affecting the index at all. So we're going to evaluate without a calculator. So we know what the cube root of 8 is. I'm hoping that you are pretty confident with identifying that the cube root of 8 right away is the value of 2. You will have a table, powers table that you can use. This is the way it'll look like on the quiz. So we're doing the cube root of 8, which is the value of 2. That's how you would read that. 2 cubed is 8, so the cube root of 8 is 2. And the negative exponent means put it into the denominator and have it squared, which is 1/4. We don't want decimals because we're not using a calculator. This is 64 to the 1/3 power squared. I took my numerator and I pull it out. Just focus on 64 to the 1/3 power. So we go to the cube. Look down to where it's 64. That's going to become 4. So the cube root of 64 is 4. And when you square that, you get 16. Pull out the -2. So at any point here, pause the video. Try some of these on your own. Don't sit there and copy me. That's not going to help you. So we're doing 125 to the 1/3 power. We don't need parentheses. We'll use our parentheses on the outside, raised to the -2 power. So the cube root of 125 is 5. The negative means you're going to put it into the denominator, and then you're going to square it. The 4th root of 1. Well, that's kind of a silly one. The 4th root of 1 is 1. That means 1 times 1 times 1 times 1 is 1. And 1 to the 11th power is still 1. 1 times 1 times 1 times 1, 1, 1, 1, 1, 1, 1 is 1. Here, just like the properties we learned, we distribute into the numerator and denominator. And you know that the cubed root, this represents cube root. We don't need to write it in that. This is the cube root of 8 is 2, of 27 is 3. You know that because the cube root of 8 is 2, the cube root of 27 is 3. When we're multiplying, some of you like to say that you add exponents, but that's only if the bases are exactly the same. So we're first going to work on taking the cubed root of 27 and squaring it, and taking the fourth root of 81. The cubed root of 27 is 3. The fourth root of 81, if you need to know, 3 times 3 times 3 times 3 is 9 times 9, which is 81. So you multiply those all together, and when the bases are the same, you add exponents. 2 and 1 makes 3, so 3 to the third power gives you 27. So again, I pull this numerator out. So the cube root of 8, we talked about, is 2. You should be a pro about that by now. To the negative fifth power. 2 to the fifth power. 2 to the fifth power, sorry, I was looking at the squares, that just wasn't working. 2 to the fifth power is 2. 2 to the fifth power. 2 to the fifth power is 32. This is 1/3, pull out the negative 2, so that's 6 to the negative 2, that's 1 over 6 squared, that's 1 over 36. Bases are the same, so we can add exponents. To add exponents, we need common denominators. So you got to think about what does 3 and 4 both go into. 3 times 4 makes 12, so 4 times 2 makes 8. 4 times 3 makes 12, so 3 times 1 makes 3. Do your best at making it look like an exponent. Don't make it even down here with the bottom of the A. It's got to be up as an exponent. Cube roots. You're going to first work with the numbers. So 81. You could look on here. Find the number 81. You know that that's made up of 3 4 times in a row. Then we have x. We could break the 6 into 3 and 3 because we have it twice in there. We have the 8, which can be broken into 3 and 3, and there's still extras left over. And then there's a 4 that can be broken into 3 and 1 extra. Now, you don't have to write it all out like that, but you're welcome to. That helps you have the visual. We're working for 3 of a kind. 3 3s, 3 x's, another 3 x's, 3 We have 3y's there. We have another 3y's there. We have 3z's. Don't forget your index. 3. You have 2y's left over, and you have 1z left over. There you go. Take each part individually. It's very doable. Okay, here. Now you might look at this 3 and wonder, is that an index or not? Well, if you look here, that doesn't have an index of 3, so this wouldn't have an index of 3. If it did, you just couldn't add them. End of story, we're done. But, so this 3 is an exponent. You got to be very careful how you write your indexes and exponents. Be sure it looks like what it is, which this pretty much does. So, the square root of 4, because that's a perfect square, because we're doing square roots, times 6, which is not made up of any other perfect squares. X, we have 2 of them in there. We have another 2 of them in there. We have another 2 of them in there. We have 6 of them in there. 2, 2, and 2. And another x to make our 7th. $54 is what? 9 times 6. 6 is matched. That's important. You got a perfect square. You got an x. So here we have the square root of 2, or square root of 4, which is 2. Square root, so you have 2 of a kind, 2 of a kind, 2 of a kind, so that's x cubed. So you're going to be left with a 6 that you didn't use and an x you didn't use. You have square root of 9. You already have x cubed out, and you have 6x. Take a look. Your radicals, the radicand and index, are exactly the same. Your variables are exactly the same. So we're adding those together. 5x cubed, 6th root, or square root of 6x. So if you haven't paused yet, go ahead and pause again. Give this one a try on your own. I wouldn't be surprised if the quiz is going to look more like this, but then you got to add or subtract. You got to do it again. So you need to be able to handle bigger problems like this. So this is 4x, 25 times 2. You have some x's, you have some left over, you have a y, you have some z's, 6 different times, which 2, index is 2, it goes in there evenly. So this is 4 times the square root of 25, which is 5. We have the x that's out there and another x to make that x squared. And we have z to the 3rd power, because that's 2 of them, 4 of them, 6 of them. 3 different sets of 2, because it's a square root. That makes a 2 that we didn't use, an x, and a y that we didn't use. So this becomes 20, x squared, z cubed, 2xy. Here we're evaluating. A couple different ways that we can do this one, but I think since your radicals are the same, this is a property that is true. 3 goes into 3 one time. 3 goes into 7 2 times with 1 left over. 3 goes into 15 5 times. So you simplified it. You did your division now. You could have simplified this down and then did some division later, or you can do it now. And the cubed root of 125 is 5. That's how you use that chart. What do you see? What you can't do is add these two numbers together. To be right, like radicals, you need the same index. We got that. You need the same radicand. We don't got that. Now, figuring out your factors of 48 can be a bit of a challenge. There's many different ways we can do it. We could have said 2 times 24 and then broke 24 down to 2 times 12 and broke 12 down to 2 times 6. And then on this side we would have 25 times 3. Okay, there's 5 times 15. There's lots of different ways we could have done it, but we want a number to match. And we definitely want a square rootable value. So we want to use numbers that come from this column. Anyway, we get 4 root 3 plus 5 root 3. Now our radicals are exactly the same. So that's almost like 4x plus 5x. That would be 9 root 3. And then with more values, okay, again, we're doing square roots. These could easily be cube roots. I wouldn't be surprised on your test if it's going to look more like this, like that, multiple times. I think only twice, but it'll be in there. These are nice, understanding the concept, and then can you apply it to some tougher problems? So this is 49 times 2. That's a number that comes from the square root column. 2 times 36 is 72. Well, there we go. So what numbers am I going to use here? 16 times 2. There you go. So we have 7 root 2, 6 root 2, and 4 root 2. 1 plus 4 gives me 5 root 2. And if they had variables, you would have to pull the correct variable out. They'd have to match correctly, so you have like terms you're adding and subtracting. Your radicand, the value inside the radical, has to be exactly the same variable, same exponent, same everything. And then you could add them together with the same exact radical in every problem, every part. All right, that's everything we got, at least for this review. Look over your notes. Look at some of those tough problems. You're going to do great. Just understand the basics of what you're doing, so then you can apply it when you get to problems like such. Okay?